difficult in psychology because so many factors can influence the behavior that is being studied. Therefore, in interpreting experiments, it is important to look for uncontrolled factors which might have affected the results. It is a mark of scientific sophistication to be able to defects in experimental controls. If you want to go into the original literature in psychology or another experimental science, you should develop this skill. Being sensitive to controls may also help you evaluate claims made in scientific television commercials or, for that matter, in any experimental results you hear or read about. Two main strategies, or experimental designs, are used to control extraneous factors. One strategy employs control groups. In the other, measures of behavior are made before the independent variable is introduced in order to establish a behavioral baseline against which to compare behavior after the independent variable has been presented. The subjects of the experiment, the animals or people in it, are said to serve as their own controls in this before and after, or within subjects, type of experiment. Control in experiments. Control groups. Suppose we decide to use the control group design in an experiment on human learning. In this experiment, we want to test the hypothesis that letting people know how well they are doing as they are learning improves their performance. In other words, do people do better when they get feedback on what they are doing? Finding that performance improves with feedback would have a great deal of practical importance. In fact, performance in learning a skill usually does improve with feedback. To test the effects of feedback, we will use a simple behavioral task, while blindfolded. The people in the experiment will be asked to feel a block of wood with one hand and to try, with the other hand, to draw lines the same length as the wooden block. The experimental group of subjects will be given feedback, the independent variable, by being told when the lines they draw are within 0.25 inches of the block length. The control group of subjects is given no feedback. Thus, the groups differ in the presence or absence of the independent variable. Ideally, when a control group design is used, the groups should be equivalent in every way except for the independent variable. In our experiment, we want to be fairly sure that any behavioral differences between the groups are due to feedback and not to other factors. We therefore match subjects in the experimental and control groups. For instance, we make sure that the subjects in the two groups are equally good at learning new skills. We might give them some preliminary tasks to do in order to check this out. The subjects in the two groups should have roughly the same ability to draw lines. It would not do if the people in one group were habitually more accurate and careful than were the people in the other group. Handedness might be important, as might general intelligence, sex, and age. Figure 1.4 top summarizes the control group design. In practice, it is very difficult to match subjects in control and experimental groups on all the factors that might conceivably affect their performance. As a compromise, subjects are often assigned at random to experimental and control groups. It is hoped that this will approximately equalize any extraneous factors in the control and experimental groups which might affect the experimental outcome. In the feedback experiment, for example, it is hoped that as many accurate people would, by chance, show up in the experimental as in the control group. A mixed strategy is often used. Experimenters will match subjects on a number of factors considered to be relevant and then assign them at random to the experimental and control groups. Control in experiments, baselines. Perhaps better control can be achieved with the before and after, or within subjects, design in which the subjects serve as their own controls. In this method, A baseline, normal level of behavior is established before the independent variable is introduced. The behavior after the addition of the independent variable can then be compared with the baseline behavior. This before and after method gives good control over individual differences among the subjects which might affect the outcome of the experiment because such individual differences are present both before and after the independent variable is introduced. If individual difference factors are held constant, change in behavior must be due to the independent variable. A before and after within subjects experimental design was used in the experiment illustrated in Figure 1.3. The 7 rats in this experiment were first made hungry by limiting the amount of food given to them. Then they were trained to press a lever protruding from the wall of the cage, whereby with each press a small pellet of food dropped into the cage. See Chapter 4, p. 152. After the rats were well trained, the number of lever presses in 15 minutes was recorded. This provided the baseline data, Figure 1.3. The next step in the experiment introduced the independent variable injection of various doses of the drug neurotensin. Each rat was injected with one of the doses, selected at random, and then allowed to press the lever for 15 minutes. 2 days later, another dose was given, followed by another 15-minute lever pressing session. These injections continued until each rat had received each of the various doses of the drug. The number of responses in catch of these test sessions was recorded and averaged for the 7 rats. Note that each rat serves as its own control in this before and after experiment. For each individual rat, its control, baseline, behavior could be compared with its behavior after different doses of the drug had been given. To make sure that the independent variable produced the change in the behavior, it is often a good idea to scale what happens when the independent variable is removed after it has been introduced. The behavior should go back to baseline levels if the independent variable did, in fact, produce the observed changes. This is called an ABA within subject's experimental design. The first A is the baseline condition without the independent variable, B is the condition with the independent variable, and the last A refers to the final test of the behavior without the independent variable. Figure 1.4, bottom, summarizes the ABA within subject's experimental design. This design is a good one to use when the independent variable does not have a long-lasting effect. Some independent variables, though, produce stable, long-term changes in behavior. For instance, suppose the independent variable is a new way of teaching children to read. If it is useful, the children will not be able to return to their baselines after the experiment is over because a long-lasting change will have taken place in them. In cases like this, the control group method would most likely be used. Replication. It is important that experiments can be repeated or, in other words, replicated. In elementary chemistry, for example, we can demonstrate that water is made up of hydrogen and oxygen simply by burning hydrogen, that is, combining it with oxygen, and collecting the water that results. Anyone with the proper equipment can do this experiment, and it has been done millions of times. In psychology, we can show that recitation is an aid to memory by having 2 groups study something, one with recitation and the other without, and then measuring the differences in memory. If this experiment is performed under the proper conditions, it will show that recitation helps memory. This finding, too, has been repeated or replicated many times. The advantages and importance of replication are obvious. If we get the same results over and over again under the same conditions, we can be sure of their accuracy beyond all reasonable doubt. Experimental findings which cannot be repeated generally do not become part of the fabric of a science. A dramatic discovery may be reported, but if it cannot be replicated by other scientists, it will not be accepted. Replication, or check-upability, as it has been called, is an essential part of the experimental method. Limitations of the experimental method. The experimental method is, in many ways, the best method for gathering scientific information. But it has limitations. Obviously, it cannot always be used, especially if the experiment might be dangerous for the subjects. A second limitation is that the method is restricted in its application. The conclusions derived from an experiment may be limited to the artificial experimental situation. They may not apply to natural situations or even to other experimental situations. Psychologists who do experiments must continually guard against this possibility and strive for generality in their experiments. A third limitation is that the method sometimes interferes with the very thing it is trying to measure. Consider, for example, an experiment on fatigue. A psychologist may give people various tests of skill and thinking before baseline, and after they have gone without sleep for 24 hours and find that they improve upon their baseline performance. After 24 hours without sleep, should the psychologist, or should we, conclude that 24 hours of sleeplessness is beneficial to complex performance? Probably not. Another variable had been introduced into the experiment, and it interfered with the measurement of the effects of the fatigue. When the experimental subjects came into the laboratory, they were strongly motivated to perform well. And this variable, an increase in their motivation to perform well, overshadowed the effects of their fatigue. Hence, the possibility that people in an experiment may not behave as they normally would must be considered when drawing conclusions from the experiment.